Hello everyone. A while back I bought some old test equipment from a reconsignment shop that a friend of mine told me about, and he found this bunch of stuff, and in that was this model G-30 RF signal generator from Paco. And I wanted to go ahead and do a restoration on this piece of equipment. I have a friend that's in need of a little signal generator to work on some AM radios with, so I figured I'd fix this, and he wanted to purchase it from me. And you know, stuff that I'm giving I'll give away. A lot of stuff I bought I'll give away, but you know, I said in that video when I got this stuff that I was going to probably sell off some of this stuff. But anyway, he wants to buy this because he has a few other pieces of Paco gear, so he wanted this, and we're going to go ahead and tear it apart and take a look at it and see if we can get this thing working. Now, whenever you got an old piece of equipment in this, I suggest not to plug it in, and I'll show you why. If we have a look here at the schematic, you can see the line cord where it goes in, and then we have our transformer. Let me zoom in on this just a little bit. Right here you can see right to start with, when we come into line cord, we got two capacitors going from either side of the line cord to ground. And the problem with these is these caps go bad. Now, most time in this configuration you would see two wax capacitors across it, but a lot of times you'll see a what's looked like a ceramic disc capacitor with 3 legs on it, and that's probably what they have used in this piece of equipment. They're 0.01 microfarad, and a lot of times these things will short out due to age. This model of generator was made in the 50s, so it's been around quite a bit. Also, looking at this, I'm seeing a single diode as a rectifier, most likely a Selenium. Transformers are 130 volts AC. Goes through the Selenium, it's supposed to have 130 volts. On the other side, goes to a 2200 ohm dropping resistor to 110 volts. Now, the problem with Selenium rectifiers is efficiency. They do not hold up very well. The harder they get, the lower the line voltage goes. So, you know, we want to try to maintain this 110 volts or somewhere close to this. I have seen these things drop way down below 100 volts easily. So anyway, enough of that. We'll go ahead and get this thing tore apart and see what we can do with it. So if we look at the unit, we can see, you know, the face doesn't look too bad. It's just dirty. The screws is rusted. The dial is, you can hear that. It has got a lot of corrosion on it. Got to be very careful with cleaning this. A lot of times it's best just to wipe it down, maybe with just a little bit of water, because you can remove this lettering. I was thinking that this was etched and put in it, but I feel like it's just printed right on it, so you can easily take this off. Also around the dial, you can see it's got a red line on going through the middle, and then it's got lettering telling which band is which, and you can see it's yellowed quite a bit. We'll just wash this with some mild detergent like dish soap and water to clean that up without removing any of the lettering. So, you know, it's got some battle scars on it. You can see the handle hardware is rusted. It's the front of the case and the sides. It's not too bad. You know, it just needs cleaning real bad. We look on the back of it. A little rust here and there on it. We're probably not going to paint it. We're just going to clean it and stop the rust. Look at this, serial number 3442. And to get this out of the case, we just simply remove these two screws. Also, I've noticed on this side, you can see the case is warped just a little bit, like it's bent in right here. We'll need to get this on something and get this straightened out. So we'll go ahead and get these two screws out and open this thing up. Okay, the screws are out. Turn it around to the side, and these things are just pressed together. Sometimes you just get your fingers right there at the edge and kind of pull it apart, and out the chassis comes. So very simple circuit. We can see our band coils over here to select which band we want. This is our main tuning condenser. We have a 6C42 here, audio transformer. This is our RF audio mode switch. Got one capacitor on the top here, and a pilot lamp. And over here on the bottom, you can see we've got another molded capacitor here. We got a dual 20 microfarad at 150 volts. Another tube here. Our power transformer. There's our Selenium Rectifier sitting down here at the bottom. And sure enough, right here, let me zoom the camera in and let you look at this. You can see that capacitor I was telling you about. Sure enough, it has it in here. And as you can see, it is already split in two. Yep, two pieces. Now, being that it's already broken completely in two, I don't know what would happen if line voltage would have came across it. It could explode, or it could have just did nothing. It's hard to tell. It's not unusual to find these in this kind of shape. So one of the first things we're going to do is just go ahead and snip this thing out and get it out of there. We'll come back and put some safety caps on the line cord after we replace the line cord. Looking here at the transformer, we got some white residue, type of corrosion on it. We'll have to clean that up. But I'm thinking the first thing we're going to have to do is go ahead and just tear this thing apart and get it cleaned, because it is very dirty. I'll go ahead and we start by removing the dial. Just one screw holds that on. If you're not sure, you know, when you go tearing some of this, just take some pictures of which knobs went where, and that will help you greatly in putting this thing back together. There's two screws here with nuts on the back. They are rusty. We'll have to get those cleaned up. And be real careful with this little plastic indicator. We don't want to break it. On the bottom, the top had these little spacers. The bottom has shorter spacers with nuts on them. No idea why they did it like that for. But now we have that off. Go ahead and just reinstall the nuts on these, so in that way we just kind of keep them situated. Now this one on the bottom here is broke out, but that shouldn't be a problem at all. So to get this front dial off, we'll turn the unit around, and looks like there's one set screw in it. Set screw off, and the dial will pull right off. Doesn't look bad, it's just you can see the corrosion that's on it. We might try to just take some car wax and try to polish this up after we wash it. And we can get the rest of the knobs off. So I removed the faceplate from this Paco G30 signal generator. And as I was doing so, I noticed there was a extra jack in the front of this thing, and this is some modification that someone has done, you know. And I've not got nothing against modifications, it's just the way you do it, you know. They came in and drilled right here where you know, it kind of messed up the lettering on the front. And I'm not quite sure why they have done this. It doesn't really make sense or dawn on me yet of just what they were doing. If we take a look here, you can see this 1/4 inch jack has been installed, and they have the ground and the outer lug tied to a red wire which goes down to ground. Now over here on the other connection, there's a 330 ohm resistor connected to that, and that is connected to pin 7 of the 6C4 audio tube. So if we look here at the schematic of this, you can see pin 7 is the cathode, and it just comes down and goes to a 330 ohm resistor and then straight to ground. And they came in and they cut the ground, moved it to the jack, so when nothing's plugged in, it's original to 330 ohm resistor goes to ground. But when you insert the 1/4 inch plug in, it takes this from ground. So I'm not quite sure what they're doing or what they were using that for. It just isn't making sense to me at the moment. But I will be removing that and put this resistor back to ground like it normally would. Now what I'm going to do about the hole in the chassis, I'm probably just going to have to put a plug in it and just let it go like it is. There's no really good way to you know, repair this hole that they have installed here. So what I'm going to do now is go ahead and get this faceplate cleaned up. Get this bend over here on the side straightened back out, and clean the dial up, and go ahead and get the chassis over here cleaned up. And you know, I'm going to just take this here and wash it with some good soap and water. Same thing with the dial. You know, I'll try just a little bit on it, you know, make sure I don't take no lettering off, and then if everything looks good, I'll go ahead and do the whole thing. After that, I'm going to wax this and buff it and see can we get the original color back into it. And you know, as far as the chassis, we'll just take a brush and go ahead and clean it up, and wipe it out with a rag, and take some compressed air and blow everything out, re-lubricate this tuning condenser, and clean up all the switches and stuff. Well, I've pretty much got everything as clean as I can get it. I did not work on the chassis as hard as I wanted to because I didn't want to take the original finish off of this. I wanted to keep that patina on it that's already there. So I just went ahead and took care of the rust spots and just gave the chassis a good wipe over with some Scotch-Brite just to, you know, loosen up any grime that's on it, then wiped it down. So that should be good. Cleaned the faceplate up, put a coat of automotive wax on it, and cleaned that pretty good. The face is pretty straight now on this end. You can see where the original bend mark was here, but that's all good and straightened out now. So what I'm going to do now is go ahead and assemble the chassis back together, and then we can get in there and start doing some electrical restoration. Okay, I went ahead and got the unit back together. Got all the knobs clean, got them back on. Removed this mic style RF jack and put a BNC jack in its place. I still got to plug this hole. Somewhere I got some little metal caps amongst my inventory here somewhere. I just got to get in here and find them, and one of those should fit nicely there. So now it's time to start our electrical restoration. That's the jack that was in that hole for the modification. When he got that removed, got it out of the way. Cleaned up the little jewel light. Looks pretty good. It really doesn't look that bad. You can see there's still some marking and discoloring on the dial itself, but there's just not a whole lot I can do with that without, you know, removing the lettering from it. And we got most of the yellowing out of the little plastic indicator on the front. I didn't want to scrub on it too hard because I did not want to remove the lettering off of it also. At the top of the dial, you can see it's graduated across the top from 0, 5 to 10. So we definitely didn't want to remove none of that off. So now we'll go ahead and get it turned over and start replacing some capacitors and see if we can get this thing back together. So I'm going to get this 0.1 microfarad cap replaced. I have the 330 ohm resistor. It's actually supposed to go to this ground lug, and then there's a wire that goes from that down to the potentiometer and to this ground lug. So we'll put all that ground back like it was. We have this dual 20 microfarad 150 volt electrolytic will get replaced, and I'll probably just put a terminal strip there because I'm going to need some more terminals when I replace this Selenium Rectifier. Now this will probably be the last thing we do because you want everything completely restored before you go changing out the Selenium Rectifier. If you remember, we're supposed to have 130 volts from here to this 2200 ohm resistor, and then 110 volts after the resistor. So we'll be changing that values of resistors until we can achieve 110 volts on this side, and this should be somewhere, you know, close, 107 to 110. I want to try to keep it on the low side anyway. I don't want it to go over 110. We also have this 47k resistor here. We'll need to check that, and we'll go ahead and check these other, there's a few of these precision resistors in here, so we'll check that. So with those two caps there, the only other cap to have to replace is this 0.02. It's a 400 volt cap. we'll have to replace that one. That should be all the caps. We do have another couple of resistors up here that we'll need to check and make sure they're in tolerance. Alright, I'm going to go ahead and check out a couple of these resistors here down at the bottom. Here we got a 2200 ohm. It's coming at about 1.94K. Have a 470K ohm. And it's checking about a little over 500K. 6800 ohm here. Checking in about 67. That looks good. 5600 ohm. Well, at 5600. These position resistors usually don't drift out that much, but these two are definitely going to have to be replaced, especially that 470K. And up on the top side, we have a 2200K. And it's about 2300. Another resistor here. I can't read the color code on it because it's a little bit hard to see it. About 11K. I checked the schematic and that should be a 10K. It's checking at about 11K. Okay, so like I got a few resistors to get replaced out. I've already replaced the 0.02 microfarad cap up here on the switch. Got that one replaced, so I'll go ahead and get the resistors and the bottom caps replaced. I'm getting ready to replace the that dual electrolytic capacitor, and you can see these are not tied directly to ground. They go through a 680 ohm resistor before they go to ground, which is that precision resistor over here on the end over here. So I believe I can put the capacitors on either side of that, but they're, you know, much smaller than the original electrolytic. So make sure, you know, when you replace this, you don't tie these to ground. Okay, I got one of the capacitors completely installed, and I just got the other one just tacked on to the Selenium Rectifier and its ground point. And what I want to do was look at the voltages. I brought it up on the variac, and everything's looking good. I want to look at the AC voltage. Should be about 130 volts. And if you can see, we're getting about 146 volts. And that's because of line current. So we'll switch over to DC. We'll look at it here at the output of the Selenium Rectifier. We had 154 volts. And then over here on the other side of the 2200 ohm resistor, it's supposed to be 110. We're getting about 132. So now we kind of know what our voltages are and about how we need to go. So what I'm going to do is get a terminal strip installed. We'll get this Selenium Rectifier out of there and play with our resistor values until we get exactly what we need. Okay, I got the Selenium Rectifier replaced. Have a 1N4004 diode across here. Installed this little terminal strip. Got the other cap in, and it's tied over here to this side. I still have the original 2200 ohm resistor in there. So when we check our voltage over on this side of the resistor, we're showing about 152 volts. Should be at 130, and over on this side of the resistor we got 123 volts, and it's about 13 volts high. Should be about 110 volts there. So we're going to change this resistor out to a higher value. And this is why I say that, you know, replacing the Selenium Rectifier should be one of the last things you do, because you want all new caps and resistors in place and everything under this load it's going to run at, so you can get the correct voltage on it. So we'll go ahead and change out that 2200. Okay, I got the new resistor installed. We went with a 330k on resistor, and I used a 5 watt because it's going to create a little more heat. So I didn't want to go back with a 1 watt. I wanted something that would be able to handle any heat, which it shouldn't be that bad. Take a look. We're still at 150 on this side, but over on the load side, about 111 volts. Get right at 111 volts, 110.9, 111. So that should be close enough to run our high voltage on this G-30. So now we'll just look at it and see if we got any signal out. Okay, I got the Paco Model G30 sitting here, been warming up for a while, and I've coupled it directly into that old bench CB radio that I have here on the bench. So I want to go ahead and test and see if we got any output at all or anything. I could just throw the scope on it, but I want to go ahead and see it and listen to it and see if it's even close to being accurate. So for 27 megahertz, we got to go to band E. Now I have the levels turned all the way down, and one thing I'm going to tell you is that you're going to use this to align a CB radio. You're not going to be able to get the levels, you know, down far enough. But like I say, you know, he's using it for AM radio and just for a single signal source. So we got it on band E, and we'll turn the dial. See just how far off this thing is going to be. It's 29, it's 28 megahertz. And there's a signal right on 27 megahertz. Now we're on 27.205 on the bench radio, and you can see we have just a little bit over S9. I'm going to turn the modulation on, see if we got any tone. Yeah, I can already hear something. Yes, our tone generator is working. I'll put it back on modulation. Again, the output is turned completely down. We can turn it up. You see it's quiet the receiver down just a little bit. And I also want you to understand you're not going to have a pure signal out of one of these things, you know, but it is alright for doing AM radio alignment. You know, if you're working on old tube radio, now you can build an attenuator to go in between the RF output and whatever you're working on. Okay, I want to check the accuracy of the output frequency on this G-30. I have it on band A. We're on 160 kcs. We can look over at the scope and we can see our sine wave, which you see is not as pretty as you would want it to be, but you know, you got to understand this is what this piece of equipment will do. And we'll roll it up to about 500 kcs, and there's our output on that. Now if we look over at our frequency counter, you can see we're at about 512 kcs. We roll it back down to 160. It's about 162, so it's a little bit on the high side. So you can see on the back of our generator, this is our band coils, and you can go into the manual and you can figure out which coil operates which band. As you can see, this manual is not the best looking manual. This is a copy of an original manual put in the PDF form. But you can, you know, go through here and pick out the number on the coil and go up in the assembly process to find out which coil is which. But the easiest way to do it is just look at the back of the unit, and you can see that there's one coil here that is much bigger than the other ones, has more windings on it, and as you go around, the windings get less. Well, the one with the most windings is going to be your low band coil. So like I said, we got it set on 160, and we're going to adjust this coil and see if we can get the frequency to come down just a little bit. Okay, let's see if we can get this one to come down some. Right, that's 160, and that's 500. You see it's reading 0.501. So you kind of have to split the difference in these things. Right, that's 50100. If we go back down to 160, that's 160. And that's dead on the 160 on the scale. You see we're at 159, so you have to split the difference. That's 500. So that's about as close as you can get this these bands to line up. You know, like in a receiver, a lot of times you will have a coil and a trimmer cap, and you can either stretch the band out or shrink the band up. With this, you don't have that ability to do, so you have to kind of play with it and get each band exactly like you want it. So we'll go ahead and go through the other bands. Okay, so we're on band B, which goes from 520 to 1700 kilohertz. So we're at about 526. Alright, that's real close to 520. Then we'll go up to 1700. and it's 1.708. We see if we can split the difference just a little bit. .704. The dial is variable drive, but here, and it's a little touchy getting this thing directly on frequency. It actually needs a fine-tuned coil in it so you can get it dead on frequency. Okay, we're looking pretty good on that band. So band C is 1.7 to 5.5 megahertz. So we have 1.7, it's going up to 5.5, 5.56. 1.72. We are very close on this one. Bring that up to 173. .73, 0.57. So let's split the difference on that one. Then we'll go to band D. So we'll go band D is 5.2. We're at 5.3 and it'll go up to 1600 megahertz. 16.5. We'll go back down to 5. We'll bring it to about 5.25. Okay, right there, and then we'll go up to 1600. About 16.4, so we're pretty much centered. Okay, we're going to look at band E now, and we're feeding it into the spectrum analyzer. I have a span of 2 megahertz. Now we start getting up in these higher frequencies, we're dealing with harmonics, and it depends on how you have the output set. If the frequency counter is going to read 30 megahertz or 15 megahertz, so it's easier just to do it with the spectrum analyzer. And you can see that we're at 15.08333. So we're just going to tune this back just a little bit. It's almost dead on 1500. Now we're going to run our way up to 30 megahertz. And we'll come over here to the spectrum analyzer and put in 30 megahertz. And look at that, 30 megahertz. That band tuned completely fine. Okay, so I got it set on G. We're at 240 megahertz. Now remember, all this is harmonics up in these frequencies, so you will see a lot of different harmonics. But you can see we are showing 240 megahertz now. So after going through that, I'm back on band A. I got it set at 455 kilohertz. Our frequency counter agrees with that. And there's our sine wave. Again, not perfect on our oscilloscope. And this is mostly where he'll be using this at, especially working on older radios, you know, to inject a 455 kilohertz signal. And as shown before, you know, we got each chord. This is A, B, C, D, E, and F. But as you see, there's no chord for G1 and G2. And you know, you can always tell it by the lower band's always going to have the most windings on the coil. So band G is a little bit different. Again, you know, this thing works on harmonics. And to set band G, you see this solid piece of wire going down here to ground. To change frequencies, you have to lengthen or shorten this bus bar going to ground. If the frequency is high, you would shorten this bar. If the frequency is low, you would lengthen this bar. Okay, and to finish up the inside, I went ahead and put a couple of Y caps, safety caps across the from each leg to ground. And this hole in the front, I just went ahead and put a binding post and grounded it, and that'll give them another place to screw on anything they want to ground through the system. And you know, that filled up the hole. Couldn't find my little silver caps I want there. Somewhere stashed away in here, but we'll have to look around for those later. Okay, so the last thing we want to do is give this thing a little bit of protection. I've got this little fuse holder, and I'm thinking about just mounting it right down here like this. That way I can jump the power wire right down to it and then take the switch wire and route it up to the other end. Okay, we got our fuse holder installed. Comes from the AC wire, comes up to the switch, then back on this black wire into the transformer, so that should protect anything. Went with a 1.5 amp fuse in this unit. That should handle any surge or anything without any problems at all. If you notice, I still have the 2-wire power cord on here, and that's because I just prefer to keep the 2-wire power cord on. Now, there's a lot of times in our videos we'll tell y'all to change it out to a 3-wire cord to you know, be more safe. But some instances on some of the things that we're running, we do not want our BNC output jack on, you know, earth. We want it floating ground. Now, you have to be careful when you're doing that, because you can, if you know, you're hooking this up to a piece of test equipment, you can blow the front end out of your test equipment, because you can pick your ground up for that. But a lot of times on some of these older radios, like some of the All-American 5s, some of the Hallicrafters, you know that those systems are floating anywhere, and you're not sure which polarity it's running on. So, you know, that's just a preference for us. You know, y'all can do it the way that y'all feel more safe doing it. But ourselves, you know, me and the guy that's going to get this, we know how to do this without blowing stuff up. So, not saying that we're, you know, all that and everything. It's just that we've been doing it for years. But I suggest, you know, you guys just getting into it, put a 3-wire ground cord on it, be done with it. You won't have to worry about it. And, you know, we always say that, you know, if you're doing this, you're following along at home, you're doing so at your own risk. You know, that is also to protect you. Anytime you're playing with any live mains voltage, you need to be careful. So I want to go ahead and check out our modulation and see where we at. Now, I don't have no big fancy analyzer or piece of equipment that'll read the level and the modulation frequency, so we're just going to use the Rigol DS1054Z to check it with. It'll be some, you know, somewhat accurate, but we'll turn the modulation on. I've got it set at 5, which will be about 50%. And we'll look over here at our scope. And we are just a shade over 2 divisions. We're at 5 volts per division. Let's say we're on 5, which will be 50%. We'll go to 10. We're somewhere around, let's see, we got 4 divisions, then half, so we're at 5 divisions. So, you know, that's not too bad. I'll turn it back to 5. Well, just a little bit, you know, 2 shades over. We're just a little bit over 2 divisions, and then down to 0. So the output level is not too bad. It's only off just a little bit, but we can live with that. But mostly concerned also, you know, this thing's supposed to put out a 400 hertz tone, and we're at about 484.8 hertz, so we're a little bit high on that. So if you look at our schematic and you see our 6C4 tube, which is, this is what produces the 400 hertz tone, and you can see our audio choke over here, and then it's fed into the switch up here to inject the signal into the output of the generator. And you look here and we see the cathode, pin 7, is going to ground by a 330 ohm resistor. Now if you remember, this resistor went to that phono jack that was on the front of the unit. Now that has me thinking already that somebody was manipulating this to change the audio frequency. Because if you take this and you change the value of this resistor, this is going to change the frequency of the audio. So here we can see that 330 ohm resistor here going to ground. So if we change this, and we have to change this drastically, I mean it's going to have to go up to probably 800 ohms or so just to get it to move that far. The thing is, if you go too high, then it's not going to pull this cathode to ground, and it's not going to put out any signal or modulation at all. So I'm going to just pop this into the resistor out, and I'm going to put a 1K resistor in there just to see what it does. Okay, so I temporarily tacked the 1K ohm resistor, and I took the 330K loose on one end going to ground, and now you can see that our frequency is 419.4 hertz, which is much closer to 400 than where we were. And looking at our level, we're still just shade over 2 volts per division. And we're just a shade over 4 volts per division on the level. So that brought the frequency down and also brought the level down just a little bit, so it lines up, you know, a lot better than what it was. So there we are, there we have it. The Paco model G-30 is back up and running and should work out just fine for him, especially, you know, working on old AM radios, old tube radios. This should give him just what he needs. Anyway, hope you enjoyed it. I know it's kind of a short video, but you know, wanted something to get out this week, and this is something I've been holding off getting done, but I want to go ahead and get it to him so he'll have something to use. Anyway, y'all have a good day, and we'll catch you in the next video. Bye now.